Hi everyone, this is Chapter 1, Lesson 1 for Slytherin, Factors and Multiples. So I've got my doodle notes here. We're just going to go over them together. So first, a factor. Okay. A factor is a number or numbers that are multiplied to get a given number. So factors of 12, I can multiply 1 times 12 to get 12. 2 times 6 to get 12, or 3 times 4 to get 12. So those are all factors, okay? There will always be fewer factors because there are a set number of ways you can multiply to get a given number. Okay? The other thing I want to talk about is multiples. So the numbers you say when you skip count by a given number. So multiples of 12, 12 times 1 gives me 12, 12 times 2 is 24, 36, 48, 60, 72, 84, 96, 108, and you can keep going. There will always be more multiples because numbers are infinite. They go on forever, okay? So a couple of things that I need to talk about. So greatest common factor, okay, I can find using my prime factorization. So basically I'm breaking a number down into its smallest form. So if we look, prime factors, if I want to find the GCF for greatest common factor of 36 and 54, I break each of them down. 36, I know 4 times 9 gives me 36, but I know 2 times 2 gives me 4, and 3 times 3 gives me 9. 2 and 3 are both prime numbers because I can only divide them by themselves and 1. I do the same thing for 54. 54 can be broken down into 6 times 9. Well, I can break 6 into 2 times 3 and 9 into 3 times 3. Then I look at the ones that they have in common. They both have a 2, and they both have a 3 and another 3. That's what's shared, right? So 2, 3, and 3. Then I multiply them together. 2 times 3 times 3, 2 times 3 is 6, times 3 gives me 18. I can also do multiples. So multiples of 3. So if I wanted to find the least common multiple of 3 and 5, I would list the multiples. So multiples of 3, remember it's like skip counting, okay? 3, 6, 9, 12, 15, and I went up to 30. Multiples of 5, 5, 10, 15, 20, and I went up to 50. Notice the smallest one they have in common is the 15. They both have a 15. Since they both have a 15 and that's the smallest one that they have in common that's the same, that's my least common multiple. So then I have a couple of definitions down here. It says a common factor is a number that is a factor of 2 or more numbers. The greatest of the common factors of 2 or more numbers is called the blank, 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 or blank. So in the first blank, you're going to write greatest. In the second blank, you're going to write common. And in the third blank, you're going to write factor. So greatest common factor, or GCF. The least non-zero number that is a multiple of 2 or more whole numbers is the blank, 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 or blank of the numbers. In those blanks, you're going to write least common multiple. So least common multiple, or LCM. All right, moving on to page 9, factors and multiples still, okay? I've got a couple of examples to work through with you. So the first example I have is this one right here at the top. Okay. There are 1 slice servings of 3 types of cake on a table. Each row has an equal number of servings and only one type of cake. What is the greatest number of servings in each row? So to solve the problem, I use common factors. So my factors of 10, which is my marble cake, are 1, 2, 5, and 10. My factors of 15, which is my red velvet cake, are 1, 3, 5, and 15. My factors of 20, which is chocolate cake, is 1, 2, 4, 5, 10, and 20. The greatest common factors, so the common factors, they all have a 1 and they all have a 5. So the 5 and the 1 are factors, but the biggest one, biggest one they have in common is 5. So the GCF of 10, 15, and 20 is 5. So the greatest number of places of cake that can be placed in each row is 5. Okay. Let's look at the second problem. It says, find the GCF of 12 and 18. So the GCF of 12 and 18 is 2 times 3, or 6. Okay. I can do this by finding the factors, prime factorization. 12 is 6 times 2, and then 6 can be broken down into 3 times 2. You can do the same thing with 18. 9 times 2 gives me 18. Well, 9 can be broken down into 3 times 3. The factors they have in common are 3 and 2. They both have a 3 and a 2, so I multiply them together, and that gives me 6. So my GCF is 6. Number 3 deals with least common multiple of 2 and 3. So the first method I can use is a number line. I can put an X above each non-zero multiple of 2 and a different color X above each non-zero multiple of 3. So I'm going to use purple for 2's. I'm going to use pink for 3's. So I have 2, 4, 6, 8, 10, 12. I'm going to do the same thing for 3's. I have 3, 6, 9, 12. Okay. The least one they have in common, where both X's are there, is 6. So the least common multiple is 6 for 2 and 3. I can also use an organized list like we did in the other example. So I can list the multiples of 2 and 3. So multiples of 2 are 2, 4, 6, 8, 10, 12, and you can keep going. Multiples of 3 are 3, 6, 9, 12, 15. Notice 6 is the least common multiple. That's the smallest one that they have in common. So the LCM of 2 and 3 is 6. Either way you solve it. The next problem I have is 4. It says find the LCM of 14 and 21 using prime factorization. Now in order to do this, I'm going to take the prime factorization of each number. So 14 is 7 times 2 and 21 is 7 times 3. Multiply using each common prime factor only once. So I have a group of 7, so I only use it once. So I do 7 times 2 times 3, or 42. That tells me that that is my least common multiple. You can use any of the 3 methods to find least common multiple, and you can use any of the methods to find GCF. So now you try the try it problems at the bottom of the page. Pause the video. When you're done, we'll go over them together. All right. So the first problem I have is Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? Now, in order to figure this out, I need to come up with either the GCF or the LCM. Because she's asking how much she charged for each bracelet, I'm going to use the greatest common factor. So I'm going to do prime factorization. 49 is 7 times 7. These are both prime numbers. 42 is 6 times 7. And 21 is 3 times 7. Notice the only number they all have in common is a 7. So she could have charged $7 for each bracelet. Okay. Letters B, C, and D all ask me to find the greatest common factor of each set of numbers. So again, I'm going to use prime factorization. So 12 is 3 times 4, and 4 is 2 times 2. 66 is 6 times 11. 6 is 2 times 3. So the numbers they have in common, they both have a 2, and they both have a 3. So 2 times 3 gives me 6. So 6 is my answer. Okay. Same thing for 18. 18 is 3 times 6, which is 2 times 3. And 30, which is 3 times 10, which is 2 times 5. Factors they have in common, 3 and a 2. So 3 times 2 gives me 6. Do the same thing for the last one down here. Okay. 32 is 4 and 8, which is 4 is 2 and 2. 8 is 2 and 4, which is 2 times 2. 48 is 6 times 8. 6 is 2 times 3. 8 is 2 times 4. 4 is 2 times 2. Okay, so I have 2 and a 2, a 2 and a 2, 2 and a 2, 2 and a 2. Okay, so I have 4 2's in common. So that's 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So my final answer there is 16. Okay. The next ones I have are least common multiples of each set of numbers. So I have the LCM of 2 and 6. So I'm going to do an organized list for this. So multiples of 2 are 2, 4, 6, 8. I could keep going. For 6, it's 6. And I could keep going, but I notice that both have 6's. So that means 6 is my LCM. Okay. For F, I have 4, 5, and 10. So for 4, I have 4, 8, 12, 16, 20, 24, 28, and I could keep going. 5, I have 5, 10, 15, 20. I noticed there I have 20s together, so I'm going to check for 10s and see what I have there. 10 is 10, 20. Notice that right there that they all have a 20 in common, so 20 is my LCM. My final one of G is 3, 5, and 7. So 3 is 3, 6, 9, 12, 15, 18, 21. This could go on for a while, okay? 5, 10, 15, 20, 25, 30. Then I have 7, 14, 21, 28. Notice that I don't have anything that's really popping up. So I'm going to go back and I'm going to look at what else I can do. Well, I noticed I could also use prime factorization for this. Well, the prime factorization of 3 is 3 times 1. 5 is a prime number, and so is 7. So all I have to do is multiply these together. 3 times 5 times 7. 3 times 5 is 15. 15 times 7 gives me 105. So that's my LCM, is 105. If you start to make a list and notice that there's no multiples that are readily appearing very quickly, you can always go and look at their prime factorization. 3, 5, and 7 are all prime, so I can do 3 times 5 times 7, which will give me my total of 105. That's my LCM. And that is the end of lesson 1.